I hope it just won't be the policy people asking questions today. I'm going to start last first. Greg, on your road sediment slide, you didn't expect any and then didn't realize any changes. I'm assuming that there was some kind of compliance check on the roads in that basin. So, I mean, does this affirm that, you know, good road maintenance equals no effect on the water?
I'm gonna turn this over to Eric in terms of compliance check. I don't know that there was any compliance check. There were just surveys. So if you're unfamiliar with the WARSAM, WARSAM has categories. So we asked landowners for categories of road traffic, you know, occasional, lots. I mean, it's big buckets. We went out, or actually I didn't go out. They went out and looked at the road surface condition and put that into the model. But we didn't do any sort of calibration except that, you know, our suspended sediment data matched what we saw in terms of the road data. Not a big change resulting from harvest. And it's nice when two different data sets come in line together. That answers your question at all. Do you want to follow up?
So just to be clear, we did not check any sort of compliance. We were just using the WARSAM model to evaluate sediment inputs into our stream, pre versus post.
Yeah, this is a follow-up to Steve's question, just a clarification for if someone could speak to the degree to which roads were either emphasized or de-emphasized in the site selection process.
I will speak to that. So I would say originally when the study proposal was first designed, we really thought there were some things we're going to be able to control a little bit more for, and one of those things was road crossings in the stream. So with the site selection process, we thought in an ideal world we would end up with this huge pool of sites that we could then randomly select from, or select from such that our blocking meant that all these different criteria were very similar within those sites, so that all of the sites in the Olympic block had 2 or 3 road crossings kind of thing. That turned out to be really, really idealistic, and in the end, really, you know, we went through a very intensive site selection process, but we ended up with the sites that we ended up with. There was no random selection of those sites, and thus there was no controlling for how many road crossings there were in any of the sites within blocks or across the whole study.
Different question for Bill. You indicated there was an increased export of nitrogen, nitrate nitrogen, and treatment effect. Can you speak at all to the source of that nitrogen, where it came from, what was the increase due to?
Well, I think it's similar to increase in discharge. When you take out the trees, you no longer have nitrogen being actively taken up by the vegetation, or at least by the trees, and until some vegetation is reestablished, you're going to have some leakage of nitrogen out of the system. And potentially there's some increased nitrification or conversion of organic nitrogen in the soil to nitrate, and then also you've got more water, so you've got more of a, I guess, a greater means of transporting that out of the system.
Okay, I got a question over here, Bill. Temperature question. This might go to you or to the biologist. I mean, we're clearly seeing consistent increases in temperature, but the magnitude is fairly small a degree in that neighborhood. And I guess the question is, how do policymakers determine what the biological or ecological significance of that kind of change is? Any comments from anybody on that?
Unfortunately, one of the things that we're missing is really good information on the stress temperatures for any of these stream-associated amphibians, which is a huge gap in understanding at what point basically a temperature change of some kind may have an effect. And one of the problematic aspects of it too is it's not simply a temperature point, but probably looking at seasonal temperature profiles and integrating that with the behavioral options that the various life stages have under different conditions. So that's something that needs to be addressed ultimately to be able to correctly interpret the results.
Thanks. I have a temperature regarding discharge, a question regarding discharge and temperature. Now, we've learned that discharge goes up with harvest and temperature went up 3%, I think, in those treatments that had no buffer, no trees. So assuming, if you could, that you take the increased water out of the equation, would you expect those temperatures to go up even more than 3%? Discharge didn't increase post-harvest? Or did you factor that into your analysis?
No, we didn't factor in flow into any of the temperature analyses. But I think if you're going to speculate, I mean, you have to look at we're probably talking about, if we're talking maximum temperatures, it's going to be in the summertime when we have low flows, and we had variable responses with low flows, with some of them being lower and some of them being higher post-harvest. So I think it's kind of hard to speculate, particularly with these streams. The difference between a low summer flow and a high summer flow might be a, liter per second. So it's not very much.
I was just curious if there was a look at how many days, if there was individual days that water quality standards were violated, if there was any tracking of high temperature fluctuations on any given day. That's one part, and then I'll just spit out another part. Also just curious if there was an average reach length that we could just have for kind of baseline understanding of how long the average reaches were. And then third, just clarifier, Bill, on the comment was made that there was a 0.9 degrees centigrade increase on the 100% and 1.4 on the forest practices on average, but then when you looked at the 7-day DADMs, they were both 1.4. So just curious if the 7-day DADMs were masking the average, or if I got that correct.
Okay, see if I can remember these. First, we didn't look at water quality standards on this. The intent all along was to keep this, look at water quality standards in a separate document somewhere down the road. So I didn't look at this with respect to water quality standards at all. Average reach length, I'm not sure what you mean on that.
How long on average these reaches were, like on average, were they 1,000 foot, 1,500 foot, 500 feet?
Yeah, I guess it depends on how you define a reach. If you're looking at the entire stream, we've got that. Each of these temperature locations are in sequential positions, going up the stream. So it depends on, so if you're talking about how much stream length there was, like wetted stream length above each of these temperature centers, yeah, I've looked at that. And there is some relationship there, weak, with, the longer you've got surface water exposed to the air, in a very general sense, the greater the temperature effect. So further downstream you go in a given buffer, you'll get, in general, very general, with a lot of exceptions, you'll get, bigger temperature response. What was the third question?
Well, do you have any idea what that average length was? Does anybody know?
Not off the top of my head.
Okay.
No.
Are you wondering about a general depiction of the total length of our main stem channel, or our stream network, or our sample reaches?
The harvest length. Thank you, Chris. That's basically what I'm getting to. And just so we can, you know, we're hearing the results, and how do they compare to the length of the harvest?
Well, I can tell you that the main stem channels ranged from a few hundred meters long to a little over a kilometer long. And
Okay.
so the average is somewhere in there. I'm going to guess 400 or 500 meters long was probably the average main stem channel length.
Okay.
And so depending on the treatment, the length of harvest is anywhere from the whole thing to approximately half.
Gotcha. Thank you. Yeah, that's what I was looking for. What didn't I get? What didn't we get?
It was the temperature response. Let's talk about that. I think there's some confusion.
Oh, yeah, thank you. Yeah, the
Yeah.
1.4, 0.9, and then the 7 DADM.
Okay, the temperature responses I presented up there were the average treatment responses post-harvest at two different sets of locations. And the 100% at the type NF junction was, the first year post-harvest was 0.9 degrees. And the forest practices, I believe, was 1.4. And yeah, I think we should probably talk, 'cause I think there's probably some confusion in the interpretation here. Or if you have a specific question about what it was, I don't.
Well, there was a statement that followed that up that said that both the 100% and the forest practices 7 DADMs were 1.4, and that's where my confusion came from.
I think they were both very similar. It's similar responses at that buffer treatment location. When you went down to the NF junction, the responses were different. But at that buffer treatment location, there were similar responses between the 100% and the forest practices.
I appreciate all of you coming out today. This is great information for all of us to hear. I just wanted to follow up on the sediment questions a little bit. We typically view sediment as adversely affecting fish at levels below visibility detection. And so I just wanted to understand the levels of significance that factored into your conclusions that there was no treatment effect on sediment. It appeared that there were increases from pre to post treatment in the sediment delivery in each of the tables shown. And it may be that there was a high level of variability or a limit to the analytical power, but I wanted to get a concept of whether there was, that was a statistical statement or a biological statement, or if those are necessarily linked as far as the severity of sediment delivery.
So on the sediment delivery, there were no statistically significant changes. And we looked, it's very coarse. These are very coarse measures. There's nothing to indicate a problem based on what we observed in terms of increased sediment delivery. And on the export, with the turbidity, again, most of our values are really small, and we don't have a lot of resolution down there at those really small values. So we have pretty poor power. If there had been a big change, we think we would have detected it. How, I don't know what that power analysis is, but it probably would have had to be, it wouldn't have been a minor change. We were looking at coarse measures, but for what we observed, we didn't detect anything, and that's just the nature of the beast.
Yeah, I think one thing to remember is that, those 90% of the measures that were less than 1.4 NTUs, 1.4 is low. And you consider, it's on a scale of 1 to 1,600 or 2,000 that we were measuring on. And, I think the turbidity measures at that level were precise, but it's just hard to correlate those back with a measurable amount of sediment. And so we've got a good portion of the time we were out there where we have turbidity is so low that it's hard to estimate how much sediment's going through there. All that we know is that it is very, 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 very low. So.
Yeah, my question was sort of a follow-up to Marty's on, and it had, I guess it's directed at Greg, so I'll wait till Dave lets go of his ear. Okay, thanks. So Greg, you gave a very, I think, impassioned talk about the need concerning discharge to look at not just the bell curve, but changes in the number of days either below or above what would be expected versus what you observed, and it made a lot of sense to me. So for different reasons, not just discharge, but potentially biologically. And so just thinking along the lines of Marty, I wonder if you had considered, or Marty's question anyway, looking at sediment or turbidity in a similar way. In other words, that while you may have detected a change in the magnitude, or no change in this case, could there be a change in the shape of the curve so you end up getting amounts of sediment, even if they're minute, that are discharged over a longer period, but they come out in the wash if you look at it from an annual standpoint?
Good question. So yeah, we did try that. And you know, one of the things we're challenged with actually is discharge goes up, you'd expect turbidity to drop, right? If just dilution, if we didn't pick up more sediment. But again, all these values are really small. And the methodology I used for discharge assumes that I can predict discharge in the treatment basin using the reference basin discharge, right? Well, it turns out that turbidity is not synchronized like that. All of a sudden, I get a spike in the reference basin, but nothing happens in the treatment, or vice versa. So sediment is a lot harder than discharge because the events aren't synchronized. We have a hard time predicting what we would expect to see in the treatment basin in the absence of the treatment, like we did with discharge. So yeah, I tried those things. I tried everything I could think of, and nothing I saw led me to, yes, there's a treatment effect here.
I have a question for Greg or Eric. I'm not sure. If I understand your presentation, Greg, you saw that there was greater erosion in the reference sites relative to the others. The bank erosion, I think that was, which to me seems counterintuitive. And I was wondering if that's just an anomalous, random kind of observation, or is there any explanation you might have for that?
So I'm going to let Eric talk about the specifics of the sites, but remember, this is just a post-treatment survey, so it's not before or after. It's possible that those reference basins are more prone to erosion. You know, I can't say, Eric may have some better idea, but erosion is also something that's pretty stochastic. You know, we get a little bank slough here, and you know, we don't get one there. It's one of those things that I think is sort of a problematic thing to draw, you know, causality to.
I just wanted to interject a couple things in specific to your question. One, you said in relation to the reference, and those values that you saw weren't in relation to anything other than themselves. So it was only an evaluation of the eroded area observed in that basin in a single post-harvest year. So there was no in relation to another treatment presented in that graphic, I think, that you're referencing.
Just to follow up on that, the erosion that we measured were the patches that were above the actual bank. And so things like undercut banks weren't a part of those particular measurements. And then to follow up on Amy's point there, all of that erosion was very small. And so even though we pointed out that it was greatest in two instances, both of which were references, it's still very, very, very small in terms of the total length and or area.
Also, I think importantly, that one where we saw the most recorded erosion, the highest value, happens to be our biggest site. So if you're just looking at the value of eroded area, the total eroded area, there's a lot more opportunity for that to be a bigger value because it's the biggest basin in our study. And what we really should focus on probably is the proportion of the stream length impacted.
I had a question about the post-treatment. You saw a much larger increase in woody debris, small and large, and I was wondering if it was considered at all if that could have acted as a storage mechanism for sediment in that post-treatment year, or even anecdotally if there was sediment stored behind some of these collections of woody debris.
I think it's safe to say that, yes, there was some sediment stored behind that woody debris. And I feel pretty confident that the woody debris is influencing some of our channel characteristics that I'm going to talk about after lunch. And that includes constraining of channels, narrowing of channels in our most extreme treatments. I'll point back to the wood as an explanation of that this afternoon.
Since a couple people alluded to the biological link relative to sedimentation, I think it's important to mention that there has been only one sedimentation study that addresses in-stream amphibians, and it was not related to forest practices at all. And it was done at a time before we had the new techniques that incorporate detectability, and there's some indication that with higher levels of fine sediment, there may be a detectability issue. And so it's a major gap in understanding what's going on with amphibian responses numerically, but I'd also like to say that we just don't have any information in context of a sediment response for particular life stages that might be vulnerable.
I have a question up here. It's wonderful to see much of the brain trust of Seymour displayed before us. My question is for the folks in the audience who are not familiar with our program at all. No, I was watching for this, and no one actually really defined hard rock or why that study was done, and why that's important about it. Someone did mention competent lithology, but I don't think that was helpful to the people who don't understand what that's about. So eschew obfuscation and bring it down to the ground here for us on hard rock and why. And you might mention there's a soft rock coming in the future. Thanks.
Thank you, Nancy. That's a great point. So there were several studies that were precursor to this that addressed amphibians, in-stream amphibians of different kinds, that gave us a strong indication that we would expect numbers that were greater on harder rock substrates. And in doing sort of the very extensive sort of pre-sampling, the feasibility to select sites originally for this study, we found very low occupancy levels on a lot of the softer rock conditions. And we wanted to ensure that we would have at the basis all the sites occupied to be able to effectively interpret a response. And that was the primary reason for it.
Thank you, Nancy. That's a good question. And I just wanted to draw you back to the confluence of events that led us to the hard rock study, and in part that was our ability to try to cover stream-associated amphibians within the Forest and Fish Agreement. So the connection to the hard rock gave us an opportunity to look at organisms in the type N systems that could act as as response variables, things that we cared about and that had ESA coverage. So in light of the way we had originally planned this 16 or 17 years ago, it was to try to get as much coverage as we could, which then led to particular types of studies that looked at those response variables.
I'm going to add a little bit more to that, too. Some of the studies on in-stream amphibians that preceded us did not verify for occupancy going into the study, and some of them were actually extremely well-designed studies. The Jackson study, for example. And what they attempted to do was to encompass the range of conditions across the landscape, but they had a number of sites that were probably unoccupied, and we didn't want to run into that situation, basically.
I think Nancy also pointed out that we ought to mention that there is a companion study going on soft rock substrates. This person can tell you about that.
Yeah, so the soft rock study came about because of, concerns that this hard rock study wouldn't necessarily apply to, and I wouldn't say soft rock, but more finer substrated streams. And the temperature might be more sensitive in those. Export, especially with sediment, could be different. And so the soft rock study is really we're doing the flow, nutrient and sediment export, and stream temperature along with riparian veg and in-stream wood. And that's ongoing now, just entering into our post-harvest, about to enter our post-harvest phase.
I have a question, Greg. Can you give us some context for the post-harvest period relative to storm events? You mentioned stochasticity is going to drive a lot of these things. It's going to have to do with the whole road erosion, bank erosion, sediment export. I mean, what kind of storm event levels did you experience in those first 2 years after harvest?
I may ask Amy if she remembers. We did something looking at the historical context of the rainfall in the post-treatment years relative to the whole history for the last 30 years. I don't think they weren't big events. We didn't have anything like the 2007 storm event. I mean, obviously that was a pre-treatment event. They were not anomalously dry years or anomalously wet years. I think they were pretty typical.
Yeah, we did see some slight increases in precipitation in the post-harvest period, but there was no formal analysis. I can't say if it was extraordinarily large or anything, but overall, on average, we did see some increases in precipitation in the post-harvest period. But other than that, we didn't see anything out of the ordinary.
I do have a graph this afternoon that also speaks a little bit to increased precipitation during the post-harvest years, at least during the 3 months of the year in which some of our surveys were conducted, in this case, our channel characteristic surveys.
I just want to make it clear that our analysis accounts for the fact that post-treatment years could be wetter or drier, so we're looking at expected versus observed. So the fact that the post-treatment years may be a little bit wetter doesn't explain the difference in the change in discharge. Again, that was change relative to what was expected.
Right, that's why we have the reference versus treatment comparison that can account for that annual variability.
Yeah. So that's a good point. So we didn't, again, yeah.
Make all the difference in the world.
If we had had a really big event in the post-treatment years, we might have expected to see more of a treatment effect. It's during those big floods that potentially, obviously, the relative increase is small in terms of peak flows. In fact, we saw it was non-existent relatively, but absolute change in discharge is big for those peak events. And so you would expect to see, that's when you get your landslides, and it's when you tend to get these big inputs of sediment that we would have been more likely to pick up. It's the nature of 2-year study. This is what on average, you might expect to see. We just don't capture extreme events in a study like this.
Hi, I have a question about site selection, so I guess for Amy. You mentioned that you couldn't come up with random sites, you weren't able to select random sites, and of course the opposite of that, the issue there would be bias. And I'm just wondering, first of all, two questions. You didn't talk about how the treatments were applied, if there was opportunity for random treatment dispersal, and also if you've investigated the bias issue at all, if you'd looked into what the implications might be for that.
So we feel that we dealt with the bias issue as well as we could in the fact that we considered for selection all non-fish bearing basins in Western Washington. So we didn't just call up Weyerhaeuser and say, hey, do you have a site we can study? We started with all of the basins that were available, and then we went through a process where we eliminated basins that didn't meet particular criteria. 36,000 basins was the number of basins that we started with. That's the number of non-fish basins in Western Washington. So does that answer that part of your question? And so then for the application of treatments, we randomly assigned the treatments when possible. So the biggest limit to that was that the private landowners, the private timber companies, were essentially not willing to supply us with basins that could act as a reference because they did not want to tie up that merchantable timber for what we were asking, which was about 15 to 20 years. And on the flip side of that, some landowners, for example, the National Forest, were unwilling to commit to applying treatments, harvest treatments, because they were worried that they would not be able to apply the treatments that we designed because of restrictions on harvest on federal lands. So when it was an option, we randomly assigned it, and when it was not, we couldn't. However, all of the treatments, so once we designated a basin, okay, there's 6 reference sites. 3 of those we knew needed to be references. The other 3 actually were randomly selected, and 2 of those are on state land, who was willing to hold those lands during the period of our study. And then one of them was actually that site that I mentioned in the introduction, where it was intended originally to be a harvest treatment, and then the harvest wasn't applied, and that was on a private landowner. And then for all of the sites that we knew we were going to apply treatments to, we randomly assigned which treatment would be applied to those treatment basins. And then the last little caveat is that for the state-owned references, we were able to randomly select which ones would be treatments and which ones would be references. So it was actually very few instances where we couldn't randomly assign the treatment.
I was just going to add a little bit of on the flow issue. I don't know how it affected your Olympic or your Willapa region sites, but there was a top 5 flood of record in 2009 in the Chehalis River. So there was a significant storm in I believe it was 2009 in the spring. As Greg described, by looking at a comparison with what was predicted versus what you saw, that probably wouldn't matter. But you may have had some pretty good rain in 2009.
Okay, let me answer that in part. So part of that tremendous rain event was because you had a stationary position to that storm system, but the stationary position of that storm system was actually right over the upper Chehalis headwaters. Yeah. And so you had a diminishing effect basically outside from where that storm system was stationary.